Hey guys, today we are going to do an example problem of a centroid. In this example problem we're going to be working on the Tetris block from Centroids Calculations assignment number 1. This is problem number 4, and in the next video we will use this exact same model to do what's called the subtractive method. But today we're going to do the additive method. Okay, so we have a 6x6 block with a little chunk missing. So the first thing that we need to do is we need to choose our shapes. So I'm going to go ahead and draw a dotted line on top here, and I will call this top shape, shape number 1, and I will call the bottom shape, shape number 2. Step number 2 is to calculate the area of each of these shapes. Since these are both rectangles, this should be pretty easy. So area of shape number 1 is going to be equal to the base of that shape times the height of that shape. This top block has a base of 3 and a height of 2, so 3 times 2 is going to give me 6. For the bottom block, area 2, we have a total base of 6 inches and we have a height of 4 inches. So 6 times 4 is going to give me 24. I'm going to go ahead and calculate the total area while I'm at it. And total area is going to be the sum of these two numbers. So 6 plus 24 is going to give me a total area of 30. Okay, the next step is going to be to calculate the centroid, or the center of mass, of these two shapes. So I'm going to do that for the x coordinates, so x1 and x2, as well as the y coordinates, y1 and y2. For both of these, I'm going to be using the rectangular centroid equation, which is, in the x direction, x equals base of the rectangle divided by 2. And in the y direction, it's going to be height divided by 2. So if I plug that into what I've got here, for shape number 1, the base is 3, so 3 divided by 2 is going to give me 1.5. For shape number 2 in the x direction, 6 divided by 2 is going to give me 3. Oops. Yep, no, that's right. Okay. In the y direction for shape number 1, the height is 2, so 2 divided by 2 is 1. And for the bottom shape, shape number 2, the height is 4, so 4 divided by 2 is 2. Now we do have to fix one number here, and that is going to be this guy. See, shape number 2 is on the origin. Remember that the origin is down here in the bottom left corner. That's our 0, 0 point, right? So all of our coordinates are with respect to the origin except for 1. And let's go ahead and run through each of these just to double check. So shape number 1, its x coordinate is 1.5. which is going to put it 1.5 units over from the y-axis. So we don't need to change that number since this edge is sitting on the y-axis. Similarly, shape number 2, its x-coordinate is x equals 3, and that makes sense because we would expect its center of mass to be right here. So we don't need to change that number because this edge is on the y-axis. Okay. We do have to change the y-coordinate of shape number 1 because this shape is not touching the x-axis. It's not on the origin. So this corner is above 0, 0. So we need to convert this y equals 1 coordinate for our centroid into a value that is with respect to the origin. Another way of thinking of this is this box is sitting on a table that is 4 inches off the ground. So if we want this box to have the right coordinate, we need to add the height of this box underneath it to that number. So if we add 4 units to this number, it will give us the correct coordinate, which is y equals 5. And we can check that by counting up from the origin, 1, 2, 3, 4, 5, and we get the number that we would expect. That the y coordinate of this is 5 units from the bottom, and that the x coordinate is 1.5 units. Alright, so now we have our centroids, our centroids for our two shapes. That's what these 4 numbers are. So now what I'm going to do is I'm going to fill in two tables, one for my x numbers and one for my y numbers. So I'm going to do this, I'm going to fill this out for each of my shapes. For this example problem, we have two shapes. We have shape 1 and we have shape 2. So I'm going to fill in one part for xi and ai. I'll talk about that in a second. Then we'll have a third column, which I'm going to call xi times ai. And then underneath that, we will do one last box where we will calculate sigma xi times ai. And again, I'll talk more about that in a second. But I'm going to do the same thing for the y direction. So I'm going to make a 1 and a 2. Put my yi here, my ai here, and my yi times ai here. And then at the bottom, we'll calculate sigma yi ai. Okay, so this seems like a bunch of mumbo jumbo, but it's not. This table is going to serve as a calculator for us to help us to measure a couple of things. So the xi in the table on the left is going to be my x coordinates for the centroids for each of my shapes. So for 1, I'm going to write in this 1.5 right here. So that's going to go right here, 1.5. I'm going to do the same thing with this 3. I'm going to switch over to my other table, and I'm going to go ahead and put those numbers in the same place. So for the y, for number 1, it's 5, and for number 2, it is 2. For the AIs, we're actually going to put in the areas of those shapes. So for shape number 1, the area is 6, and that's going to go in both tables because it's the same shape. For shape number 2, that area is 24. Alright, so our table is almost done. What we're going to do now is we are actually going to multiply these numbers across, and then we will add them together at the end. So let's go ahead and do the multiplication. So 1.5 times 6 is 9. And 3 times 24 is 72. Moving over to the other table, 5 times 6 gives me 30. And 2 times 24 gives me 48. So I've multiplied across. And now I'm going to add down. So those numbers that I just got, I'm going to add them together. So 9 plus 72 is 81. And 30 plus 48 gives me 78. So again, these numbers might seem random and not really related to anything, but these numbers are actually one of the numbers that we need. We have these formulas that we use to calculate the centroids for the x and the y coordinate. For the x direction, the equation is sigma xi times ai divided by sigma ai. And in the y direction, or the y centroid is sigma yi times ai divided by sigma ai. Alright, so these numbers aren't random. This top numerator value in this x equation is actually 81. That's the number we just got. So go ahead and stick this guy here. And I'm going to do the same thing for y. That's my sigma yi ai number, that 78 that we just calculated. So the question is, what's sigma ai? Well, sigma means sum, right? So sigma a would be the total area. And we already calculated that. We calculated up here. The total area is 30. So we're going to just plug that in, divided by 30, and it goes in both equations because it's the same number in both. So if you plug those into a calculator, in the x direction, you'll get 2.7. And in the y direction, you'll get 2.6. So the coordinates for our centroid for this problem would be x equals 2.7 and y equals 2.6. And that's how you do number 4 from the homework. So I'll make another video in just a minute. That'll be the subtractive method of this same problem. You'll get the same answer because it's the same shape and it's got the same centroid. But it's important to try it both ways just to make sure that you understand. See you guys later.